Whoa, awesome. Okay, class, let's go with it. Let's see. We have today is the 15th. We have 1.9 due for lecture stuff like that. We also have 1.7 due. So we're going to take, let's see, 1.7 questions if we have any.
Yeah.
And then we're going to take 1.8 questions if we have any, but 1.8 is due on Monday. We good? We have a little test coming up. Say again?
Yeah, 1.8 we did.
I don't know. Wait, 1.9?
No, we finished
1.9, we're going to talk about 1.9 today.
1.8 is due on Monday. 1.9 today.
Okay, we good there. So do you guys got a study guide in your hands just now? This is what's going to be on the test. Let me get to the study guides real quickly here. That one? No, that one right there. All right, we have something like looks like this. So this exam, notice there is no calculator section yet. We'll get to a calculator eventually, but we go from 1.6 on. So 1.6, if you go back to your homework, you should have something called evaluate the function for the indicated values. You should have something about graph the function. Remember, this is the parent function section, right? This is the one that you should know. I should say, give graph for me the square root of x, and you should know like, oh, it goes this way. Graph for me x cubed. You should know the way the graph goes. All right, the 1.7 is now the fun part. This is where we sketch the function on the same coordinate and we start moving things around, right? The transformation, stretching, vertical or horizontal, compression, vertical, horizontal, reflections, or shifting. Any of those. And then 1.8 we covered last time. We can add, subtract, multiply, and divide functions. We can also compose them. Oof, okay. And then today, hopefully we'll get done today, we're going to show something called inverses. And inverses again, and then inverses again. I think we're going to talk about inverses. Got this funny feeling. We're going to talk about inverse. Honor students, here it is. There's a more difficult inverse question. And then we got some application questions. So if you understand the stuff above, you should be able to understand the application questions. Yes, So write down whatever you like on a sheet of paper. One sheet, front only. I think, is that right? Yeah, front only. And please bring it with you to an exam. So I'm hoping that by the end of, so don't throw those away. I'm hoping by the end of the year, you pretty much have 1, 2, 3, 4, 5, 6, 7, 8, or recreate it again if you're Luke. So you should have about 8 sheets of paper that cover the whole entire class. We good? It's going to be the whole entire, and then those would be your, that should be your stuff for the final. And if you want to add more to it, like you took the test, and after you do the corrections on the test, like, oh shoot, I forgot how to do the midpoint formula. I totally forgot to write that one down. So write that in. So it's kind of like a flowing thing. By the end of the year, you should have literally 8 sheets of paper that cover the whole entire Algebra 2 class. Which I think. So again,
Wednesday.
test is Wednesday of next week. If we get through 1.9 today, or at least for the most part. Do you guys have a lot of tests on the day? Seriously?
No, well, I think we just have the history test.
It's okay.
Okay.
It's fine. If
I mean-
any other day you move it, will be equally as.
No, okay. Because I'm thinking if we do need to move it, we can move it to the 22nd if need be. That's my little
I would prefer to do it on Wednesday, so we have more time.
more time. Okay. Gotcha. Okay. With that said, let's jump to here. And what else we got here? We have, of course, start off with this right here. We have a, whoa, that went sideways. There's only half his face.
Yes, we did.
We have a dice trick. We good? You guys have to figure out what he does and how he figures it out. We good?
We already did this.
Not this one. This one's cool. Ready?
Different dice trick.
And We talked about the last one though, right? We talked about the last one? Yeah, we talked about how that works. Okay.
Again, from Martin Gardner's book, this is an absolute classic, I think. 3 dice, D6s, and I've got my blindfold. I'm gonna pretend I can't see. I actually can't see. Now I could cheat, I could look through this thing, but I'm not, right? And the point I'm gonna show you is that I don't need to cheat. There's a way to. So I'm gonna ask you to roll the dice. I'm gonna blindfold myself from now on. Can you grab those 3 D6s and roll them for me? So I'm gonna ask you to just add it up. I know that's pressure, but
Okay, I can do that. I can do that. Okay. I've rolled them.
can you add up the 3 numbers?
Yes.
Keep this total running in your head. Obviously, I can't see them now. Choose one of the dice
Okay.
and check the number on the bottom, show the camera, and add that one. Make sense?
Yep. Okay.
Can you re-roll that? And add the one on top of that one that you just re-rolled onto your total as well.
Yep.
And now, if you want to, leave the totals pointing up, but like put the dice together, so I can't tell which one got re-rolled or anything. The point is that I can't see anything about which dice you re-rolled, and I missed the re-roll.
Yep.
All done?
Yep.
I'll take my blindfold off now. But I've missed the crucial stages, and you're thinking of a number in your head. There's no way I could know.
Wow.
Good there or no?
Yeah. You're so smart.
I know. And he just smiles at the camera like, ha, I got you. So let's see, he re-rolled this one right here, the red one. Re-rolled it. And
Your stages, and you're thinking of a number in your head. There's no way I could know if the number is 16. Except I do.
he's smiling. And he still smiles, yeah.
I think he's like,
Hold on, that's not the one. But that's not the one I wanted. Hold on one second. Let me find out real quickly here. Okay, there's that one. There's the addition one. I thought this was the better. One second. Let me see if I can find it just real quickly here. We got that one, the hidden faces. No, we got the hidden face one already, didn't we? Yeah. Okay. I'll find the one I really liked.
I'm pretty sure that I know how that one works.
Cool. Okay. So
Obviously, just straight up magic.
he did not look through the
I think they're
blindfold.
gonna be like, yes, of course, no one comes easily, but I just put on the blindfold.
I haven't seen that one before, but
Because he re-rolled it, right? So how do you add the addition if you did not re-roll it?
well, basically, the original numbers that you have, whatever those two are, they're always going to add up to 6 plus 1, because on a dice, the top and the bottom of the dice is always, no matter which side you have, the top is going to be one number that adds with the other one to be 7 always. So then just by looking at the other ones, you can tell pretty easily.
Very true, Noah. That is so cool. So on a die, if you look on a die, if you flip a die over, right, it's 1, and then the other bottom is 6, right? If you go 3, the other one is 4, right? And 2 and 1. And so remember what he told
So
him?
then you
He
can
told
just
him
add all the
to,
other numbers,
yeah, he told him
because that's all you need
to
find.
he told him to go and add the bottom of what he did, right? So he had that 1, right? And then he added 6 more. Well, that's a total of 7. So who cares? So when he turned around, he looked at the top ones, he added those, and then he added another 7 to give you the total, right? Because he had what? He had 2 on there, he had 3, and then he had a 5.
I had never seen that.
And then he just added 7 because the person added the 1 and the 6 earlier when he had them. So that was an easy one.
Right.
So if you do everything, what time you're gonna get it right?
Say again?
So add up the top three numbers that you keep it.
Yeah, so let's see, he rolled a 1. So this one, he stayed the same, right? This one was a 3 still, right? I'm not sure what the numbers are, but he rolls a 1 first time. And the guy tells him, look on the bottom and add whatever is on the bottom. So this grand total is 7, no matter what you do, right? If you roll a 3, it would have been a 4. He would have added 7 each time. Then what he does, he re-rolls that one. He gets a 2 out of it. So then all he does is just adds this stuff up. that he has, and then he adds a 7 on top of that, which would be the summation of the top and bottom of the previous roll. So he was tricky. At first, it kind of doesn't make sense, right? Because we don't play with dice as much, right? We don't have that sort of feel understanding of it. I think that's what makes it.
That one just kind of, I didn't know for sure. if that
Good
was
job,
right,
Noah.
But I kind of guessed.
Uh-huh. That's awesome. Okay, there's one more I wanted to show you, which was kind of cool. It's a little bit better. It's kind of like the summation issue, just I thought was a little fun to see. Okay, anyways, let's go with it here. So we got, how much do we have? We have 25, 30 minutes. We have inverse functions in our hands. You guys ready to go? Oh,
So ready.
That one just clicked in my brain. That doesn't.
that's good. Could have been clicks. It's a light bulb. All right, so let's go with it here. So I have one function called f of x. F of x is x plus 7. Easy enough. I like the number 7 today. And then we have another function. Ready? We're going to do some notation real quick here. This guy's going to have f, and it's going to have like a little -1 right on top. It's almost like an exponent, but it's not an exponent. And it has f of x. This one's going to be x minus 7. Okay, the way we say this is f inverse of x. And that little inverse part is this little guy right over here. So let's talk about notation for a little bit. So let's talk about notation for a little bit. If I see a number like this, just sort of standing there by itself, this guy, everybody agreed? You better agree.
Yes.
That's a -1, right? If I see a number and then a -1 inside the exponent of a number, we good? So the base is a number.
So isn't that?
What does this guy mean? Starts with an R. Reciprocal. Yeah. We should start a chant. Go, Joe. Go, Joe.
Isn't that?
Okay, so we got a -1. We have reciprocal, and then we have this guy. So if it is in front or on top or on the top right-hand side of a function name, it means in mathematics, we just run out of notations. That's all. That's what's happening here. So 3 different, one same symbol, 3 different meanings just based upon where it's sitting. Okay, sitting by itself, it's a -1. Sitting on sort of in the exponent position of a number, it's a reciprocal. Sitting in exponent position of a function, it means inverse. Now, what in the world is an inverse? So let's talk about that. Inverse undoes the work of the function. We good? How about this? Is undoes a word? Undoes? What do you guys say? Okay, undoes. Not a, but the work of the function. Undoes the work of the function. That's what an inverse does. So let's kind of put a few little, let's do it by sets here, a little set notation. Here it is. If for the first one, for the function itself, if I have 1, if I plug in 1, what will be the answer?
-1.
If I plug in 1 into here.
Oh, sorry, 1 or 7, 8.
8 is good. Yeah. All right.
Could not.
Third try, no problem. 8. If I plugged in a 4, answer is 11. All right. Awesome. And we'll just do 2 of them. That's no need to do more. All right. What does the inverse function do? The inverse function is going to undo the work. So if I were to plug in an 8 into here, I get out.
No, you get out.
8 minus 7.
Yeah.
So 1.
The answer is whatever. or 1. It's Friday. Okay, notice what's happening here. The inverse function is going to undo its work. So how about if I stick at 11 in there? Answer will be 4. Okay. That's it. That's what we're going to work with. It just takes little interesting things to work with it here, but let's go with it. So first things first, do you guys remember from last time in 1.8, we did something called the composite function. Remember that? How you stick one function into another function? So with inverse function, hold on. So let's do this here. How about if we stick a 2 into the function, off to the side here. Give me 2 into the function. 9, okay, into the top one. And then if I stick 9 into the inverse function, 2. So if I were to stick the function inside the inverse, we'll write the notation for it in a little bit here. All it's going to do is just going to give me back to 2, right? If I do this thing, if I put in the 2 into the function and I put a 2 in the inverse function, it gets me back to 2. So how do you write that in terms of composition function? Here it is. It says if f of x and f inverse of x are given, so it means they're inverse functions of each other. We know this for sure. We know that f composed with f inverse of x will just give us x. We'll see that in just a bit here. And we know if we go the other way, if we say f inverse of f so let's try our example from the previous slide here. Example
Saying if
from
you put in y, then you would get out x in an inverse y.
I don't want to say it that way. So let's do this here. This is going to be x plus 7. This is x minus 7. So can you guys do this operation from Wednesday's class? And I'll do the first one. You guys get the next one here. So I think the way we do it is like this. It's the inverse, the f inverse stuck into the prime function. Is that right? Like this? We write it like that. Talk about math changing. You guys ready for this? When I was in college, these guys were reversed, meaning, just not to confuse you here, this in college, this actually meant because it was like, oh, the inverse is supposed to be outside function. Is this whole debate in mathematics of which one should be the inside function, which notation is better. And so math changes. It's the funniest thing. So now the first function, we say, yeah, we'll just write like this. It's easier on the notation. Okay, let's go with f of x minus 7. Is that true, you guys? What worked last time, right? We stuff this function inside here. And what we're going to do now is going to stuff this function into this function. So we're going to rewrite, the f function. And each time you see an x, you're going to write x minus 7. So let's go with it here. This is x minus 7 plus 7. And what do you guys say? Say again? Equals x. Yeah, the 7 and the minus 7 are going to undo each other's work. And that's how you know something is an inverse function, because it just undid the work of the other.
Why would we make the +7 again?
Plus 7 is from right over here. So what we did is we stuffed this x minus 7 into this x right in here.
Oh, okay, right.
Okay, you guys go the other way here. So can you guys do this one? Because both of them have to work. That means the inverse function is undoing the f function. Now here, first one was the f function is undoing the inverse function. Here, the inverse function is doing the f function. So can you guys do that one? And again, it has to be x. Yes, give you guys a whole, or roughly speaking, 32.7 seconds. All right, some are done already here, so I'm gonna put this in so the way we write it like that. And then the function itself is x plus 7 this time. And we're gonna plug that in, so it's gonna go the other way this time, right? It's this function here now, going into that x right there. So now it's x plus 7. Is that right? Okay, x plus 7 minus 7 this time. And then of course you get x anyways, because again, both functions have undone the work of the other. That's what we got as an inverse function. Okay, so now exercise 1. Show the two functions are inverses of each other. Okay. Here it is. Now I'm gonna not label. I can't put f prime or f inverse here, so I'm gonna just label two different functions. I have an f function, I have a g function. Show me that these two undo the work of each other. You got to go both ways, right? You have to show that f composed with g, and you got to show g composed with f. Anybody know what time we're out of here? I think it's 20 after. No. Okay. So I'm going to go with you guys here just so we go faster. So we have to show this one. We're going to show two different ways. We've got to show this. And then we have to show this. So they can give you a whole bunch of different functions. Yeah, these are just the easy ones. You can do x squared, sure. There would be a square root somewhere in the other one because square roots undo squares. All right, g of x is given as x over 4. That's an easy one. And the f function, what it does, it multiplies everything by 4, right? You can kind of tell there's going to be the difference, right? Because g divides by 4, f multiplies by 4. Obviously, they're going to undo each other's work. 4's cancel, done there. We got to go this way. We also have to go the other way to prove that they are inverses of each other. Golf and fog. What did you learn in algebra today? We learned golf and fog. Okay, are we good there? You guys tell me if I'm going too fast, I can slow down. We good? Or go back?
Golf and fog.
Fog and golf. All right, a little bit more complicated for you guys to try here. Let's see. How about two more people still writing it down? Please tell me. If I go to the next slide and you're not done yet, please just tell me. If I can go back to the previous slides, no problem. Cool. Okay, B, all yours. I have f of x is 5 over x minus 2. G of x is equal to that right there.
for G is the part of the
No, it is on the outside. It is on the outside. So let me start here. Let's see if you can be ahead of me. That's awesome. This is going to be f of, and I'm going to write in this right here. Okay, now the fun part begins. As I'm going to rewrite f, I'm rewriting f. And that x is going to be the new stuff. We're good. So let's see how this works here. So 5 is on top. Oh boy, 5 over x plus 2. Put that in parentheses, because that kind of helps me. But does that make sense there? So if I do maybe a little bit more work here, if I want to just get rid of the parenthesis itself, I'm going to have this, this, this. What cancels now? I think the 2's are gone. Is that right? 2's are gone. And this time I can actually maybe put this like 5 over 1 and then 5 over x. Would that work a little bit? Just because I have a single term on top, single term on the bottom. Change it to multiply. This guy stays exactly the same. This guy, we take the reciprocal of it. We change the operation to multiply instead of divide. 5's are gone, and voila, these guys are actually inverses of each other, at least the first way. We know that f is the inverse of g. Now the question is g the inverse of f? But I prove it both ways. And g on the outside, this time it's 5 over x minus 2. Plug it in there. All right, let's see how this happens here a little bit. So I'm thinking g is this guy. So 5 on top. The x is all by itself on the bottom, but this is 5 over x minus 2. We get a plus 2 at the end here. Oof. Okay, so I guess I got to deal with this one right here first. So let me rewrite it on the next slide because let me rewrite this x minus 2 right here, plus 2. Let me rewrite that. So I'm going to deal with this little piece right here only. This is going to be 5 over 1 multiplied by the reciprocal of this guy coming through. Everybody okay with that change? I changed it from division to multiplication. 5's are gone. I'm left with x minus 2 plus 2, and I get myself the x. So now I know the g undoes the work of f. Now I know these guys are inverses of each other. Da, 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 da. Okay. I got so excited about 1.9, I forgot to do the homework questions, huh? From 1.7 and 1.8. Let's do this here. I got 2 more things to show you, which we can do kind of quickly here. On Monday, we'll come back. So don't turn in homework 1.7 today. Let's do on Monday, we'll just do, yeah, we'll do one. Did you guys turn in 1.6 to me yet or no?
Yeah.
Okay, so 1.7 and 1.8. No, 1.7 we'll do on Monday. Yeah. Okay, 2 more things to show you. Let's see if we can do it in 5 minutes or less here. Graphing inverses. How does the graph, you guys will have some graphing problems on the homework here. How do the graph of inverse work? And so let's take a function. Let's graph a function of 2x minus 4. Let's see if I do that. I think I can graph this. I think we know how to graph this one. 1, 2, 3, 4, 1, 2, 3, 4, 5. Now let's see, we start down at 1 to negative 4. And then we go up by 2 over 1. So up 2, 1 over. Do it again, up 2, 1 over, and we keep on going. Up 2, 1 over. We can do this for a long time. Let's see. You don't hit the. What happens if you don't hit your dots? You make the dots bigger. Okay, so let's see. Hey, you know what? This is interesting. Let's see. This is. People might even stop here. Let's see. This guy and this guy. This guy is a 2, 0. Is that true? This is a 0, negative 4. This guy is 1, negative 2. True. And this guy is 3, 2. Everybody agree there? Let's do one more. Let's go up 1, up 2 over 1. What is this guy? Okay. So let's talk about this here. The inverse does what? Inverse. Hold on. The function takes the x and makes a y, isn't it? But doesn't it go from here? 0 makes a negative 4. What does the inverse function do? Yes, it takes the y technically, right, and gives it back to 0. So can you guys plot all those points just going the other way? And we're running out of time. So how about negative 4, 0? Let me put this a different color here. So I have myself negative 4, 0. I have myself a negative 2. No, that's not negative 4, 0. That's negative 4, 0. Negative 2, 1. 0, 2. 2, 3. Are we good there? Hey, that's weird. 4, 4 is going to become 4, 4. So we have this little line, and then can you guys give me the equation for this line? That should be easy because we have all the information there. We have our slope and we have our x-intercept.
1/2 x plus 4.
1/2 x. Where does it hit the y-intercept?
4, 4.
Thank you.
Oh, sorry. I missed it.
Plus 2. Okay, so we notice a few little things here. We notice that what we do is we just change x's and y's, but if you were to flip it over, you know how we do reflections? The red line and the black line flip over on this little line right here called, hey, the identity function. Remember that one, the identity function we had, or f of x equals x? Okay, we ran out of time, so let me stop there. Let me tell you what you guys can do up to now. 1.9 homework you guys can do up to. I'll show that f are the inverse of each other. Yeah. The inverse.
Have to do 1.2 again.
We could do up to 15. 1, 2, 3, 4, 5. Just 5 problems, 6 problems.
So 1.7, 1.8 are
I messed up because I didn't have to take questions on 1. So 1.7 only. It's big.
So on the actual test, I wanted to talk to you about that. So I was really stressed when I did the test, and I made some really dumb mistakes because of that. Such as this, I have no idea what I was doing there. And then on the next page, I looked at this and I'm like,
That's something you should know.
And then, so,
Is it because you're not, because I know you forgot that you were doing.
yeah, well, that was part of it, and then it was also mostly, just, I get really overstimulated. Time I just could hear everything.
Gotcha.
And so it was like a lot at that time. And so I know most of the stuff. The only one I don't understand is this one, which I should understand, but I can't figure out where I went wrong. The equation of a circle.
The centers are 3,
Oh.
1, and then this is a 9 squared, but the radius is 3.
Okay.
So it
And
should
then
have been-
the other one that I had a quick question about, so I'm pretty sure. Maybe I'm sorry. Oh, it's this one. Oh, never mind. Oh, that should be -5. And then I have the radius there. Yeah. There. Oh, yeah. Just I'm not sure how to do it. Maybe. Yeah.
Let's try that in a second.
We'll figure out a way that works. Absolutely. Yeah. Okay, are we done then for the test? That's the one that we needed?
Yeah, that was pretty much all.
Okay, did it come up or no?
Yeah.
Okay. Yeah. Found the whole awesome shirt thing. So, like, how do we get?
What did I do? I'm just checking make sure it's right. It says sea level top. Does that have like the assignments for like?
Yes.
So that.
No, of course, that is, that's for chapter 2,
Oh,
but not chapter 1. Let's see, we are in chapter 3 though. No, where are we at? Chapter 2.
no, just what I was confused about.
No, I gave you the wrong sheet. Let me email you the correct sheet.
Oh, okay, but yeah, I was wondering about that.